Now we are going to graph the original function and the derivative when given the graph of the second derivative. Let's start by observing the graph of the second derivative to draw the graph of the first derivative. As you can see, the graph of the second derivative is negative from the interval -5 to -2. This means that all the points between -5 and -2 on the derivative graph will have a negative slope. Next, we observe that from -2 to 1 on the second derivative graph, the slope is 0 at the value y equals 2. This means that on the interval -2 to 1 on the derivative graph, the points have a slope of 2. Finally, let's look at the interval 1 to 5 on the graph of the second derivative. From 1 to 3 on the graph of the second derivative, the values are positive, which means that from 1 to 3 on the derivative graph, the points have a positive slope. Then, from 3 to 5 on the second derivative graph, the values are negative, which means that from 3 to 5 on the derivative graph, the points have a negative slope. When the line crosses the x-axis on the second derivative graph at x equals 3, this equates to the value x equals 3 on the derivative graph having a slope of 0 and being a max. Once we have the graph of the second derivative, we can graph the original function. The interval -5 to -2 on the graph of the derivative has a negative slope, which means that the interval will be negative in the original function. Next, we observe that -2 to 1 is a linear function, so the graph of the original function will be parabolic in nature. However, it is important to note that there is a corner at x equals 1 in the derivative graph, so there will be a hole in the original function at x equals 1. Finally, from 1 to 5 in the derivative graph, all values are positive, so the slopes in the original function in this interval are positive and reach a maximum at x equals 3. This concludes this video segment. We hope these videos have helped with graphing the functions and their derivatives.